This is my first video in a series that I'm making over what we call exploratory data analysis, and this is a little bit different than traditional data analysis in that in traditional data analysis we often look at the center of the data and its spread corresponding to a mean value for this data set and as well as the standard deviation. In exploratory data analysis, however, we often organize data using things like stem and leaf plots, and usually our primary measure of central tendency in the EDA here, which is exploratory data analysis, is the median. Okay, we don't look at the mean as much as we look at where the 50th percentile would be, and also the primary measure of variation in exploratory data analysis is the interquartile range, or not just the range of the whole data set, and not the standard deviation, but the range of the middle 50% of the data. So we're often looking at the middle of the data with the median, and then the spread of the data by using the interquartile range, which recall is the distance from the end of the middle 50% of the data to the beginning of the middle 50% of the data, or the end of the third quartile to the end of the first quartile. So notice here that I say that the primary graph used to represent our data is called a box plot. And so in this video, now that we've defined what exploratory data analysis is and what we use the median and the interquartile range to measure the middle and the spread, we're going to talk about what the 5-number summary is and essentially how you construct a box plot that corresponds to a given set of data. So first things first, when we discuss the 5-number summary, we define it as being a set of data involving 5 values: the minimum, Q1, the median, which is Q2, Q3, and then Q4. We say the maximum, okay? And essentially these are the 5 numbers that correspond to the quartiles in our data set. So you always, when we talk about box plots, need to have the 5-number summary. So we're going to start by finding a 5-number summary for a set of data here. So let's say, for instance, a stockbroker recorded the number of clients she saw each day over an 11-day period, and we have the data here. So it says what we want to do is find the 5-number summary for this set of data, which means we need to split this up into quartiles. So first things first, is very important that we put this data in order before we do anything else. So it seems to me that 23 clients was our minimum value here. So we have 23. Looks like we have another value in the 20s here. We say 29. I don't see any other 20s. So 29 followed by the 30 that lives right next door to that one. So 30. 33. We have a 31 right here. So then 33. We'd say 31. 33. 38, I don't think we have anything smaller than that, so 38. So 38. I do notice now that there's a 27 that we had missed, so I'm going to go ahead and throw on this 27 right here, and hopefully it doesn't bother us too much. Sorry about that. We say, okay, what else? Well, we've got a 40, 42, 43. So we have a 40, 42, 43. So we're going to cross these off here. And then 51. So first things first, I want to make sure that we do have all the data. So it's always good to go back and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here are our 11 data. So in order to find the 5-number summary, let's go ahead and start with 2 of the very obvious numbers that are part of this 5-number summary. That would be the min, which is our smallest datum, and then the max, of course. I'll capitalize the M on max, kind of a traditional thing to do, lowercase on the min. But we say here are 2 of our 5 numbers. Now, in order to find quartiles, what we'll do is we'll find the median of this data set, and then we'll find the median of the first half and second half respectively. So the median would be, let's see, counting in 23, 51, counting in 27, 43, 42, 29, 30, 40, 31, 38. So the middle datum is this 33 right here, and we're going to give this a label. We call this Q2. It is the end of the second fourth of data here. So now, to find Q1, we need to find the median of the min and Q2, or the median here. So we'll say starting inside the median. That's kind of the rule of thumb here. We'll start at the 31. We say counting in from 31, we have 31, 23, 30, 27. So 29. 29 is our Q1. And then we'll go over here, we say starting at 38 and counting in from 51 here, we say, all right, 40, 43, and it looks like we land on this 42 here. So this is our Q3. So our 5-number summary, and I think that it's appropriate to write here, we say the min, the end of the first quartile, the end of the second quartile, the end of the third quartile, and then our maximum. And we get these values here. We have 23, 29 clients after the 23 here. And we say 33 clients is the middle datum, or the median. We say 42, and then last but not least 51. So now, What we want to do is we want to construct what we call a box plot, or sometimes called a box and whisker plot from this data. And so if you wanted to read through this description right here, you will see that I go kind of through a wordy definition or kind of description of how you would basically construct this. But what we have here are 5 values. And so I'm just going to go ahead and skip straight to this down here where it says let's construct a box plot with this. What we're essentially going to be doing is this. We are going to construct a number line that is able to accommodate these 5 values over here. And by accommodate, I mean we only really need to choose a frame or a window that's going to fit in these values. So if I had to go from 23 up to 51, it might be a safe bet to maybe go from 20 up to 60, and we'll go by tens or something like that. So I'm going to pick a value here. I'm going to say starting at 20, and we say 30, 40, 50, 60. And this isn't very well constructed because you usually want to use the whole number line here, but we want to label this, and we say this is the number of clients per day. And this was over an 11-day span, and so you could write that in here. But essentially, what we're going to do is we're going to put a dot, is what I would recommend you do for each of these 5 values. So for instance, 23, I know that here would be 25, so 23 would be about right here. Above the number line, I'm going to put a dot, and this dot corresponds to our minimum data value in our data set. So the next dot will belong above the 29. We say 29 is just before 30, so I'll put that also above the number line right here. 33, okay, so 35 would be right here, so 33 would be maybe right here, 33. And we say, okay, so 42. Now 42, here's 45. 42 would be about right here. And then last but not least, 51, which is just a shade above 50 here. And so where we get the name box and whisker plot from is essentially this. It says that we are going to draw a horizontal line from the minimum datum to Q1. So we say that our minimum is here to Q1 is there. We're also going to draw a horizontal line from Q3 to the maximum datum, and these are going to be what we call our whiskers. As far as the box goes, we say we draw a box whose vertical sides pass through Q1 and Q3. So we have a box in the middle. We say that the sides of this box, they're vertical and they pass through Q1 and Q3, and we're just going to connect these here. So we say here's our box, and then we always put a line through this right here. So in terms of what we see right here, what I want to do is I want to point out a few things about this, starting with that right there. That right there is our Q2, or our median datum. So we read box and whisker plots often, and again, exploratory data analysis really concerns itself with where the middle of the data is. And we say, well, it's about in here, okay? We know it was 33, but we see that the middle is right here. We also look for the IQR, the interquartile range, which by definition, recall that numerically we'd say is Q3 minus Q1, which in this instance happens to be Q3 is 42, minus Q1 is our 29, value 29. So we get a distance of 13 units, or 13 clients, we say in this particular case. But that would be from here, Q1 to Q3. So I'm going to label this up here, and we say that the IQR really represents the span of this middle distance here. And we say that again, this is 13 clients. Okay. If we were to discuss the entire range of this data set, now the entire range would be from the min to the max. We notice that range here would be 51 minus our minimum datum, which was 23 here. So we would get, let's see, we had a distance of 28 clients across the entire span of this. Okay. So a few other things. This is our maximum value, of course, and this is our minimum value. But when you make a box and whisker plot, essentially we are looking at where's the middle and how is the middle spread, the middle 50% of our data spread. But that's essentially what EDA is, and that's how you find your 5-number summary, as well as how you construct a box and whisker plot. Cheers.